All right, so recently you guys saw a vlog where I got my very first 3D printer, and we've now added another printer to the mix here. So this is actually the Ender 5 Plus. This was also provided to us by Micro Center, so we could not be more grateful to Micro Center than we are for kind of sponsoring our entire forte into 3D printing. And since then, as you can see, I've been printing some stuff. So we're gonna talk about my 3D printing experience so far, what it's been like, and then kind of take you guys along for the ride, trying to get the Ender 5 set up. We have some upgrades, although that won't be happening on today's video. And then we'll show you guys how some of the prints have been going and kind of give you some feedback on how the lulzbot's been. And yeah, so if you're interested in 3D printing, take it from a noob who's 10 years late. EVGA is proud to announce their new X570 for the Win motherboard. With multiple RGB and ARGB LED headers, fin stack heatsink, switchable BIOS, and 15-phase digital VRM, the X570 for the Win motherboard brings EVGA's legendary build quality and performance to Ryzen processors. To learn more and see the full feature set, follow the link in the description below. So first and foremost, one of the things that I've noticed regarding the lulzbot versus the anything else is how incredibly out of date the Cura software is for lulzbot. So lulzbot requires that you use the lulzbot edition of Cura. Well, lulzbot went bankrupt a few years back, and it was purchased by another company and then revived. The problem is that company has not put any effort into updating the software. So Cura has moved well beyond the lulzbot in terms of new features built into the software that really make certain prints easier, give you more functionality to make your prints better, and the lulzbot just doesn't take advantage of it, although the hardware would absolutely be able to take advantage of it. The software side of things, the company has just been riding on the name and not actually doing anything to better it after they purchased it. So the Ender is going to provide us a couple of things. One, it's a lot cheaper than the lulzbot, but it also gives you a really good tinkering platform. So this is not a direct drive extruder. I do have hand me the direct drive gears. I do have the direct drive upgrade that we will install, not today, but eventually, which will then make our upgrade will be available there. There's tons of upgrades available for these. The nice thing about the Ender 5 Plus is that it's got a huge build bed, over 13 inches squared, actually 13 by almost 16 inches high. So I could print even bigger stuff for this, like shrouds and stuff for computers. Because remember, my 3D printing goals here are to use them to take our themed builds and custom parts I want to do for computers to the next level. And even maybe make models with, that way I could send off and have something CNC machined or whatever. So if I were to get something dimensionally correct as I want it in 3D printing, that can be used then by a CNC machine shop to create the CAD to make it out of metal or something. So it gives me the option to really start moving forward. Before we get the Ender software, or the Ender 5 Plus up and running, and then the printer and stuff going on here, because see, we're stuck now on add printer, because obviously we have to have the printer on. We haven't even fired it up yet. I want to show you guys how the prints have been going. So first things first, tons and tons of cubes and whatnot. This isn't even all of them. I melted some of them with a torch the other day because I got mad, so that was fun. But anyway, these CHEP cubes, basically just show you, they're calibration cubes, so you can check things like temperature, bed level. The top on these had some holes because of the fact that the flow rate was too low. So there's a lot of tuning that you do. You gotta get not just your axes and stuff set up correctly, the temperature based on the material that you're using. The flow rate, as flow rate's affected by temperature as well, because the higher temp, the faster it will flow. So if you leave the flow rate, let's say 95%, and you up the temp, you're effectively also upping the flow rate because the hotter plastic will ooze faster than something colder. It's like a toothpaste bottle, right? It's just rolling up and squeezing it out one end. So if that toothpaste were hot, it actually will come out faster than if it were cold. So there's a lot of tuning that takes place. Like this little cell phone holder right here. Got my phone on me? Yeah, I printed a Recaro chair as a cell phone holder. It works, I swear. But this was out of PLA Plus and versus PLA. And you can see the temperatures and stuff weren't set right. It's really coarse, and I painted it, so it's really ugly. But it's really coarse. There's stuff sticking out everywhere where the seams were. It's just a bad print overall, like really bad print. You got these pawns that you can print, and you'll see I make notes on the bottom, like what were the temps I was printing at. Like this was a temperature test here. So I was checking what the temperatures were. That's 210, that's 215, 220. The benchies, like this is a pretty rough benchy, but it was also at a lesser resolution because I wanted to get through it faster, just because we were checking for specifically the bed level, which look how terrible that looks. Like you can't even read it. But they got better as time went on. This is one of the more recent ones. That was a 0.5 resolution. It's not awful, as you can see, but anyone that's printed the Benchy knows that this is a pretty tough print because there's no support material in these arches. And then this was one that I painted that also looks terrible. Because I also want to see like what happens to the layers when you paint them. Will the paint fill in the layers or will it look like crap? Well, in my instance, it still look like crap. This is a Stitch model that's actually quite a bit more difficult than I was expecting it to be. I was printing this for my daughter, and this is like the second one I printed. It's very challenging in the curvature of the ears, right? The the support material that builds in between his chest and his paws, the feet get support material. But you can see here I clearly had some first layer adhesion problems on this one. So that's why it's all stringy and terrible. So then I printed another one, which yes, this one looks terrible because I was actually seeing what would happen if I used body filler, not body filler, like spray filler, primer filler. Would that fill the gaps? And then I started sanding it, so that's why it looks terrible. But again, some weirdness under his chin. So if you look under the chin, you can see it's very stringy. Like the layers were actually drooping away from the previous layer, so it didn't adhere to the layer above it. This one was worse, as you can see. That's pretty bad. I mean, I tried to file it down, and there was no filing that, it just looked awful. So one of the things I set to print last night after spending hours and hours and hours of tuning was this print of Stitch, which I think, and yes, all the support material is still on there. I want to show you guys the breaking away of the support material. I think this one turned out already, based on what I can see, 1,000,000 times better. So I can't get on to printing the cool PC stuff y'all want to see. Like I printed a bezel, which honestly I'm going to be reprinting because I think I can do a better job at that bezel now with the amount of tuning that we've done. This is done with the Lulzbot, which has a 0.5 nozzle, whereas the Ender has a 0.4. So the Ender is going to be even better at doing finer prints in more detail than something like the Lulzbot. The difference is the Ender takes 1.75 millimeter filament, whereas the Lulzbot takes 2.85 millimeter filament. So I will be updating the head on the Lulzbot to also accept 1.75, although it will still be a 0.5 nozzle, so I can at least have one size material to use everywhere instead of having like material for that machine and material for this machine. All right, let's start breaking away the support. Because some of his legs don't touch the ground, the support material had to be put there to support it right there. So it's a little rough right there. I still think this might have been a little too hot, but since it's on the bottom, I'm not too concerned with that. You can just see, I printed this at a bigger layer height. Look at that, it looks like a topography map. I mean, look at the roughness of that. This is surprisingly stuck. There we go. It's like digging boogers out of Stitch. Look at this. Last time I did this, it just immediately broke away, like the whole thing just went. But you can see here how some of the support materials kind of fused to his foot. I still think it might have been a little bit too hot, even though I made it colder. This is kind of the nerve-wracking part because this is where you can literally wreck your model. Come on. Oh, I hurt the finger. But it broke away nicely.
It's so scary.
I know.
Because the sound of the model breaking and the sound of the support material
is the same.
Is the same exact sound, yeah.
This ear turned out flawless. This ear had a little bit of droop right there because the support material didn't actually touch right here, interestingly enough. So that's why it's perfect and a little droop. This is the kind of stuff that I would just clip it and do a little sanding and be like, you know, call it a day. This support material was really stuck. Unfortunately, his leg wasn't. No, it's fine. I'm gonna super glue this back together. See, you won't even be able to see it once it's back on there. There. Stay there, Stitch. It's okay, I'll end up printing another one. I've gone through like an entire roll, 1,000 gram roll of white PLA just to try and get these prints. I did print my wife a sign, a little Disney love sign, because she loves Disney. And that took a lot of material, and that was like a 15-hour print. All right, let's get the Ender 5 up so we can start getting something to print there. Latest release, we focus on quality. I wish Lulzbot did. So I feel like 0.16 to 0.2 is where I'll spend most of my time. 0.2 was kind of like the medium on the Lulzbot. That goes 0.15 up to 0.35. But remember, the bigger nozzle makes it harder to get fine detail. So layer height is just that thickness. Does nothing about the actual like thinness of the layer, you know, the material itself. It's gonna come out thicker. So it's like the fine nozzle on a squeeze bottle versus the fat nozzle on a squeeze bottle. Which you're gonna be able to draw, dicks with better. The fat one if it's mine. Why are you laughing? I need mine.
Whoa, that screen is fancy? What?
Yeah.
Well, that does not look
It's a touchscreen?
Yeah. Oh my god.
Okay, so click leveling. So the 1.75 is pretty much the industry standard now. But if I show you the 0.285, you can see it's definitely you versus the guy that's just a friend from the gym. So this is why I'm looking forward to the 1.75, although prints might take longer even, because 0.4 nozzle is gonna not be able to put down as much material at a time. I feel like the Lulzbot's gonna definitely fill a gap for us in big prints, things that need to be large and maybe a little bit less perfect with accuracy. This is where I want to use the Ender 5 in small, more detailed stuff.
The BL Touch will make up for that for the variance across the board.
It does pop in and out like a penis.
It's a little electromagnet, dude.
Oh.
So bed leveling on this one here, there's 6 spots, right? No, more than that. There's 5 spots where it measures. And underneath the bed, you can see there's a knob under here that he's turning. So he's taking a sticky note and he's using it as a feeler gauge, basically, between the nozzle and the bed, to where he's turning that knob to where the paper feels a slight resistance of the nozzle touching it. Then he goes to the next spot and does the same thing.
You've heard gap spark plugs.
Yeah, it's like gapping spark. That's why I said feeler gauge. It's like gapping spark plugs, only you're doing it with your bed level through those knobs. Let me actually show you how we do it on the Lulzbot. All right, so the Lulzbot actually has a circuit that runs through the nozzle. So the nozzle is actually electrified, and that thermistor is next to it. That's a little round, the little dome-looking thing right there. So this is gonna go home right now. Okay, so I can come over here now and just go motion, and then auto Z align, right? So I make sure these 2 switches are perfectly level, and then level bed. So what's gonna happen now is it's gonna zero everything out, it's gonna send everything home. So the head's home, the bed's going home. It's gonna heat the nozzle up to 160 degrees. And then before it does that, it's actually gonna end up wipe. Actually, it may not even wipe, it may not need to because it's cold. Ooh, see how hard that pushed that down? That's the downside of Lulzbot right there. So because of the fact, so that could actually cause damage, the way it was like, blah, pushed that so hard. If you leave filament loaded like this and then it's sticking out a little bit, then what'll happen is it doesn't touch this metal piece and complete the circuit like it's supposed to. It at least recognized this time that that's a problem. So it's heating the nozzle up, and it's gonna wipe the nozzle right here on the white pad, because it recognized like, hey, we didn't feel a circuit there. So it's much more automated. But in my opinion though, this system has been hit or miss. Sometimes it does like you just saw, where it'll even try and damage my bed. Like, see these chips in the edge of my bed? That's because it was so far off one time when it's supposed to touch these corners with the calibration cube and then measure itself that way, when it does all of its backlash, it was hitting the bed and just like, that's not supposed to happen. See, it touched it and it recognized it. So now it's gonna hit that one. See, it did the same thing again. Do you see now, like I'm probably spending more time now than he is. So it's warmed up to 170 degrees at the moment. No. I'm stopping it. So what I'm gonna do right now is I'm actually gonna heat the nozzle up to like 190, turn it off, brush it with the brass brush. With it off, I did blow a 5 amp fuse. Where'd it go through? Oh, right here. I did blow that guy. Fortunately, they gave me 5 extras because I was like, and everything turned off. So that was a little scary. I thought I broke it. The filament's creating a barrier to where the metal isn't touching like it's supposed to. That's why it's pushing down too hard. The second it touches the metal, it'll stop, back off, and then go down slowly. And when you do long prints, the nozzle gets dirty. It gets dirty on the sides and all that. So it's important to keep it clean. This is true for pretty much any printer, I think. But I've got to keep going now until it's cool enough to where it's not oozing anymore.
It does it in a 4x4 grid, so it'll be more precise.
So you know which side you
Yeah,
have
well,
to move?
mine's automated, and I just have to clean it and redo it 16 times. So what you should know is this time is on the first touch, it'll be like, bah, and it won't push down. It'll go, bah, come up, and then slowly go down. Because now that the nozzle's all clean, it'll have a good contact. See? It didn't even push it down that time.
So, it even made a sound too. It clicked, whereas before, because the filament was in the way, right?
See? Yes. The problem is that flex, when it pushes down and doesn't can't feel it, can actually damage the bed and the bushings that it slides on. Probe successful. Okay, we're leveled. I'll do a calibration cube right now that we can compare with the one that Ender does. So you can see all the grids right here. So it's done 1, 2, 3, 4, 5. It just did 6, and it's going to do it across the entire bed. Whereas my bed level on the Lulzbot workhorse is only the 4 corners. And we found some prints that it's like almost like there's a little dip maybe in the bed where the material looks different in the middle part of the print versus the sides, and that's all about bed level. This is fun to me. It's just now I want a space to put all my printers. I want like an army of Enders just printing things all the time. I did come back to a spaghetti monster once at home, printing again the stitch because of the fact, and I even have a photo of it. I'll show you guys what it looked like right here. Because of the fact that like halfway through the print, well, I guess towards the top of the print, one of the pulleys that holds the belt on, this pulley right here, like that holds this bed belt, that bolt came off, and so that just popped off. So the bed was no longer moving, and the head was just doing its thing left and right only. So the rest of the model turned 2D and just went up. And then it got all stuck to the nozzle and everything. This has a direct drive though, which is nice. So it means it has gears that are pulling it through rather than that mechanism pushing it up through. So the fact that that tension and everything is right at the nozzle, I think makes it a little bit nicer. But I mean, I'm not saying this is a bad printer, but this is a $3,000 printer. That one's under 600. And so far that one's gonna definitely give us more precise prints, I think even out of the box versus this one. But that one has a lot of modifications available to it, which would still make it far cheaper than this. You could probably build 2 Ender 5 Pluses for the price of this and get better prints.
So that's like more of a hands-on stick shift car, project car kind of thing.
In fact, so Jetman, my moderator, if you guys have been in my live streams, works in the 3D printing industry. He specifically said, this machine holds your hand, but it's not great at what it does, and the software, again, Cura has multiple versions behind, like major versions behind. Whereas that is much more like, it's not gonna hold your hand, but you will get better prints and more reward once you modify it, and you start to learn the ins and outs of that machine. But hey, Micro Center even carries those mods, like that direct drive system I got at Micro Center. So I'll do 205, because that's what I'm running at the 2.85.
Oh yeah, this is like the same exterior.
Oh yeah, so you just have to push the spring down.
Yeah.
Okay, so the gears are just here versus over there.
Yeah.
It's getting hard to push now. I think we're there.
Oh yeah, you're there.
Okay.
Cool.
Oh yeah, it's already oozing out.
Yeah.
I made a question mark!
What?
All right.
Baby's first print.
Okay, well it's just pooping now, so. So here's the Chet build cube right here. Sliced it, set the temps and stuff. So for this one, I'm doing 205C. One thing I noticed is the speed on this said 80 millimeters per second versus 40 over there. So that means this printer might print twice as fast as that one at a more detailed. If 80 doesn't, that seems fast. I don't know anything about Ender. So if it comes out all like blurry, then we'll know. Cube. Yeah, so the name was too long. It wasn't showing up, and Nick knew that because he's used this software. So prints, there we go. So this should take, I thought it shows a nice detailed process with times and stuff. So this is why you do these test prints. Phil's gonna see this for the first time on camera. He can't see this high.
Yeah, I'm too short. That's not a cube.
Look at the skirt. Look at this, just like snotting. Yeah! Okay. I made a cube, guys! All right, hopefully the camera can pick this up. So this is the Z-axis, or I guess it looks like the N-axis from your perspective. You can see that on the Lulzbot, it's much coarser because it's bigger material, right? But there's all these dots in it because I'm still tuning out this top layer. For some reason, those dots appeared. But you can see now on the Creality unit here, just how much more uniform it is. The lines on the inside here are much straighter and just overall cleaner. If we look at the Y side here, the Lulzbot is now on your right. You can see the Y looks much more crisp. This is 0.16 layer height. This is 0.25 layer height. So that's why you're gonna see many more lines or thicker lines in the Lulzbot cube versus the Ender 5 cube. The pattern on the bottom has a texture on the Ender 5 simply because it's got a textured build plate, whereas the build plate, and this is gonna be very hard for Phil to get, remember it is white. The build plate on the Lulzbot is smooth, so the only texture we get is the actual print lines itself. If we look at the actual chip letters here, again, the Ender 5, much more crisp. You know, the best way to explain this too, like in computer terms, this is like running big format, low resolution monitor. So it's be like a 720p on like a 30-inch monitor. And this is like a 1440p panel. Like it's just sharper, everything about it. One thing you'll notice too is if we look down, and we find a smooth side here, put them like this, you'll notice that the Lulzbot on the top, all the corners sort of bulge out. They have kind of a roundness to them. Whereas on the Ender 5, they're much more square. And the reason for that is the Lulzbot bed is moving. So on the Ender, all of the printing is happening through this bar right here. Forward, back, left, and right. All the bed has to do is move up and down. The Lulzbot bed is actually moving for one of the axes. So that movement, that's a heavy bed, has a bit of a jerk to it, or think of it like a suspension in a car. When you turn the car real quickly, the suspension in the car leans. That's what's happening on the turns of the Lulzbot. And believe it or not, this is actually, with some of that tuned out, it's still that bad. So if you want real sharp edges, you know, obviously that's not gonna be as good as, say, the Ender 5. So they each have their place, and it's funny that I feel like the Ender 5 print matches the Lulzbot, and it hasn't even been tuned yet. This is the initial print that we finally got to work. As you can see, we had some issues here, obviously, because this was just set up. We had Z-axis set improperly, so the entire print was floating above the bed. So it was just squeeze bottling it down, and that's not gonna work. So you get this mess. Once we figured it out, we get this. Well, no, we get this one. So anyway, I'm excited now. This means we will be able to actually get some fairly decent prints here for computer stuff. I'm gonna probably reprint that bezel now for my computer screen with black PLA, because I have black PLA for this printer, 1.75, which I think if I do the textured side down, right, the face, that'd be neat. I think that texture would actually be neat to look at rather than print lines. So I think that's what I'm gonna end up doing with that. That's where we're gonna end this video, just sort of a vlog taking you along for the ride of the 3D printing stuff. I'm excited, this is all new to me. I got in it at a decent time where there's a lot of advancement both in the software and the capability of the hardware, where if I'd started out on this like years ago, it would have been a lot more frustrating and a lot less reward, I guess you could say. So we got a mess to clean up though. We have to put it over there, and we have to figure out permanent homes for these. Otherwise, the more I move the units around, the more the bed level gets out of whack, and they're not intended to be moved around a bunch. So I need to keep this one, that machine for now. Is, like I already showed you, this is all the stuff that I was doing prior to. I need to do a benchy now also to see how it does compared to the other unit over there. All right guys, these are my two printers. I have a feeling the Lulzbot might end up not being permanent fixture in terms of 3D printing for our purposes here, but I'll definitely find use for it. I feel like I want to get a small army of Enders once they're all tuned, because then I can be printing all kinds of stuff. Thanks for watching, guys. We'll see you in the next one. And thank you, Micro Center, once again for sending us all this stuff, because wow, it's kind of overwhelming, you know, so thanks for that.